Imagine sending money to a friend, and halfway through the transfer, the database crashes. Does your cash vanish into thin air? That's exactly the kind of nightmare Acted exists to prevent. In this episode of Data Explained, we're unpacking the four quiet guarantees: atomicity, consistency, isolation, and durability that keep your data honest even when everything else goes wrong. So let's make this concrete. Anna wants to send Bob $100. The database subtracts it from her account, and then, right at that moment, the server crashes. Bob never gets the money. Anna's already lost it. $100 has just evaporated. So the real question is, how can a database promise that a multi-step change either fully happens or doesn't happen at all? That's exactly where ACD transactions come in. Before we go further, let's nail down the word transaction. Think of it as bundling several operations together and telling the database, treat these as one single thing. If everything works, you commit, and it's all saved. If anything goes wrong, you roll back. And it's like none of it ever happened. So in our example, Anna's debit and Bob's credit live inside one transaction. Both land together or neither does. That all or nothing promise. That's the A in ACID, and it's where our story really begins. So here's the full picture. ACID is really four promises working together. Atomicity says all steps happen or none do. Consistency means the data always obeys your rules. Isolation keeps simultaneous transactions from tripping over each other. And durability guarantees that once you've committed, your data survives, even if the server crashes a second later. Four guarantees, one trustworthy database. Let's start with the A, atomicity. Think of a transaction as a single atom. It can't be split. Either every step succeeds or none of them do. Picture our bank transfer crashing right after Anna's account is debited, but before Bob is credited. That money hasn't vanished. On recovery, the database rolls everything back, and it's as if the transfer never happened. Now to the C, consistency. Where atomicity cared about all or nothing, consistency cares about the rules. Every transaction has to leave the database in a valid state, so a balance can't quietly go negative. An order can't point to a user who doesn't exist, and an email column won't suddenly hold a duplicate or a number. If a change would break those rules, the database simply refuses it. That brings us to I, isolation. Picture two people clicking buy on the very last concert ticket at the exact same moment. Without isolation, both read one ticket left, both succeed, and you've just oversold the show. With isolation, the database serializes them. One gets the lock, the other waits, and by the time it looks again, the count is 0. Each transaction behaves as if it were running alone.
And finally, D, durability. Once the database tells you committed, that promise has to hold even if the server loses power 1 second later. The trick is the write-ahead log. Every change is written to disk before commit is acknowledged. So when the machine boots back up, it replays the log and your data is right where you left it. Committed really does mean committed, not just sitting in memory waiting to vanish.
So let's bring all four back together in our Anna and Bob transfer. Atomicity means both the debit and the credit happen, or neither does. Consistency keeps the total money in the system unchanged. Isolation makes sure another transfer running at the same time never sees a half-finished state. And durability guarantees that once it's committed, no crash can take it back. 4 quiet guarantee, turning 2 risky updates into 1 safe transfer. Now, isolation isn't actually one size fits all. It's more like a dial you can turn. At the loosest end, read uncommitted lets transactions peek at data that hasn't even been saved yet. Fast, but risky. Read committed tightens that up and is the common default. Repeatable READ guarantees the same query returns the same rouse, and serializable, the strictest setting, behaves as if every transaction ran one after another, safer at the top, faster at the bottom. You pick the trade-off. Stepping back for a moment, ACID isn't the only philosophy out there. On the other side, you've got BASE, the model behind many NoSQL systems, where ACID prizes correctness and strong guarantees, perfect for banks, orders, or inventory. BASE goes for eventual consistency, trading that strictness for massive scale and availability. Think social feeds, analytics, caches, different jobs, different tools. So when do you actually reach for ACID? Anywhere wrong, data costs you money or trust. Payments, where balances simply must add up. Inventory and bookings, where selling the same seat twice means an angry customer. Checkout flows, where the charge and the order record have to happen together. And anything legally exact, records that need to be provably correct. In all these cases, you almost always want an SQL database behind you. Before we go further, let's clear up a few myths that trip people up. ACID doesn't mean your data is invincible. It protects committed transactions, but it won't save you from a dropped table or a corrupted backup. NoSQL can do ACID too these days. MongoDB and others now offer real transactional guarantees. And no, you don't always want the strictest isolation. Serializable is the safest, but it's also the slowest. Pick the level your correctness actually needs. So, what's the trade-off? On the gain side, you get correctness you can actually trust, no half-finished changes, safe concurrency, and commits that survive a crash. But you pay for it in throughput and latency, in the overhead of locking and coordination, and in the headache of scaling horizontally across many servers. ACID isn't free, it's a deliberate choice to spend performance on peace of mind. And the good news is, once you decide that peace of mind is worth it, ACID is everywhere you already work. PostgreSQL gives it to you out of the box. MySQL delivers it through the InnoDB engine, and even SQLite, running from a single file on your laptop, is fully ACID compliant. The vocabulary is universal too. Begin and commit, wrap your transaction, rollback, undoes everything if things go sideways. And it's not just SQL anymore. MongoDB now supports multi-document ACID transactions as well. So let's pull it all together. A transaction is just many operations bundled into a single unit of work, and ACID is what makes that bundle trustworthy. Atomicity means all steps land or none do. Consistency keeps your rules intact after every commit. Isolation stops concurrent transactions from stepping on each other. And durability guarantees that once you've committed, that data survives, even if the server crashes a second later. So here's your quick decision guide. If you're touching money or inventory, don't even hesitate. You need ACID. If you're operating at massive scale and a little lag is acceptable, BASE might serve you better. Anytime a change spans multiple steps and has to be safe, wrap it in a transaction. And if you're just building a typical app and aren't sure, reach for Postgres. You get ACID for free. If today's story clicked for you, there's a whole series waiting to take you further. SQL versus NoSQL, how indexes actually work under the hood, sharding, caching, and more deep dives like this one. And when you're ready to move from theory into running Postgres for real with proper tuning, backups, and hardening, head over to Dargslan.com courses, because ACID is just the start of building data systems you can actually trust. Now I'm curious, have you ever been burned by a missing transaction? Maybe a double charge on a customer's card, stock that got oversold during a flash sale, or data that's saved halfway and left you cleaning up the mess on a Friday night. Drop your story in the comments. These war stories are how the rest of us learn what ACID really protects us from. And that's ACID: atomicity, consistency, isolation, and durability. 4 quiet guarantees, doing a lot of heavy lifting behind every reliable database. If this one finally made the pieces click, hit subscribe and stick around for the rest of the Data Explained series. You can find everything over at dargslan.com. Thanks for watching. I'll see you in the next one.